Today's topic is rational exponents. I can statements, rewrite radicals and rational exponents, simplify rational exponents as radicals. Vocabulary. You will want to have your number system graphic organizer to review those vocab words. Two ones we're going to focus on today is the parts of a radical. Radical has the whole radical symbol. The radicand is the number inside of the radical, and the index is the number outside. We also call the index a root. And a rational exponent, if you remember from your graphic organizer that a rational number can be written as a fraction. So we're going to be dealing with exponents that have a power that is rational. This is a review of the properties of exponents. If you know these rules, you don't need to write them down again. If you want to have them in your notes to be able to reference later, copy them down. Example 1, review of simplifying radicals. To simplify a radical, we want to break down the radicand, the number inside of the radical sign, to its primes. We can start by saying what times a number will give me 128. One option is 4 times 32. Now 4 can be broken down again to 2 times 2, and we like that because 2's are primes. And 32 can be broken down to 4 times 8. We can keep breaking this down till they are all primes. Bring down the 2 2's. 4 can be broken down to 2 more 2's. And 8 can be broken down to 3 2's. Since we are dealing with a square root, we want to look for pairs of the same number. We have 1, 2, 3 pairs of 2's. Out of those pairs, 1 2 will come out, leaving us with 2 times 2 times 2 outside of the radical, and then we had this 2 still inside the radical. We can multiply everything on the outside to give us 8 square root 2. Let's try simplifying a higher root, cube root. We still simplify the radicand by finding what numbers we can multiply by. 135 is 5 times 27, and x to the fourth means there are 4 x's. You can write them out singly. Well, 5's a prime, we like that, but 27 isn't. 27 is 3 times 9. Well, I know that 9 is 3 times 3. So 27 is 3 times 3 times 3. And don't forget the 4 x's. Now, because we've been dealing with a cube root, we need groups of 3. We have a group of 3 here and a group of 3 here. So 1, 3, and 1x goes outside of the radical. Inside the radical, we still had this 5 and this 1x. And don't forget to add the root, which is a cube root. Example 2, rational exponents written as radicals. We are going to rewrite these rational exponents into a radical form. To do this, there's a fun saying to remind us how. Power to the tower and roots underground. Well, we are going to use the word power and roots to help us figure out how to do this. Power to the tower means it's the one on top. Well, the number on top in the first example is 1. So that's our power. Roots underground, meaning the bottom. The bottom number is the 2, so that's our root. Well, to rewrite this as a radical, let's start with the radical symbol. Our radicand is going to be the base for x, and our power is a power of 1 with a root of 2. We've rewritten it as a radical. Let's try another example. Draw the radical symbol. The base is the radicand. Power of 2, root of 3. So 5 to the 2/3 can be written as the cube root of 5 to the power of 2. Try the last one on your own and check it with me. Radicand of 6y, put parentheses around it because it's all raised to the power of 3 with a root of 2. Example 3, radicals written as rational exponents. We can still use the same saying, power to the tower, roots underground. The base is our radicand, and the power of 5 goes on top as the tower, and the root of 2 goes underground. Let's try another one together. 2x is our base with the power of 3 with a root of 4 underground. Try the last one on your own. Be very careful with what is the power and what is the root. The base is 10. It has an invisible power of 1 and an invisible root of 2. Example 4, simplifying rational exponents. To be able to simplify a rational exponent, we can rewrite it as a radical and simplify the radical. Let's start with rewriting. 49 is the radicand with a power of 3 and a root of 2. Now we're going to simplify this radical like we did in our first example. 49 to the third means 49 times 49 times 49. That would give us 117,649. We really don't want to simplify that number. It would take us too long. So instead, let's think about what 49 to the third means. 49 to the third means 49 times 49 times 49. Since we are looking at a square root, we need pairs. We already have one pair, 49. Let's take that pair out, leaving us with 149 still inside the radical. Now we just need to simplify the square root of 49, which is a perfect square of 7, leaving us with 49 times 7 equaling 343. Let's try another example with a variable. Rewrite as a radical. Power of 4, root of 3. What this means is we have 4x to the fourth, so 4x times 4x times 4x. One more. And we have a cube root, so we're looking for groups of 3. Well, we have 3 4x's. We can take one out. And left inside is 4x. Now let's see if we can simplify 4x as a cube root. That would go to 2 times 2 times x. We don't have any groups of 3, so 4x times the cube root of 4x is our simplified radical. Lesson recap. I can rewrite radicals to rational exponents and vice versa, and I can rewrite to simplify expressions. If you still need help, rewatch the video, watch additional resources, or come in for help.